2 divided by 16 is
10.165.
10.1 times 10 to the negative 3 minus a negative 4.
1.
So 1, positive 1 times 10 to the 1. So our answer for this force is right there. So let's just round it up and call it 100 newtons. That's what it is. 10 times 10 to the 1 is 100, right? So we have found this. That's 100 newtons. Okay? That's the first part of the problem. We're ready for the next part. We have a third charge. And it's right here. And it's positive, right? And we call it, let's call it C. And so the charge on it is QC. So now, what's the value of the charge, Rashad? 1.5 microcoulomb. And what's the distance between these two charges? R, A, C. What's that distance? 3 centimeters. Okay? So now, what I need to find now, I need to find the net force, which is the overall force on this charge. But if I'm going to find the net force on this charge, I'm going to need to first find the force of this on that. Are you with me?
Yes.
So what do we call that force? F of what? C on A. We need F of C on A. We already found F of B on A. Now we will need F of C on A. So in this calculation that I have here, everywhere I see a B, I'm going to replace it with a
C.
With a C. Okay, so this was my C. Now it's 1.5. 1.5. This is 1.5. This is 3. See, it's 3. This is 3. Now, you following me?
Yes.
And this at the bottom is going to be 9, because 3 squared is 9. So I have 9 here. And at the top I'm going to have 9 times 6 times 1.5. That's going to give me 81. That's 81. So up here I have 3, 9, and this remains the same. So now 81 divided by 9 is what? So this is 9. So it's now 9 times 10 to the 1, which is what? 90. So this force is 90. Oh, and by the way, I should have drawn it, right?
Right.
What does this do to that? Push. Push it. So this force that I'm just now calculating is going to go like this. This is F of C on A. Okay?
Okay.
So these are the two forces that are acting on this charge. So now I need to find the net force. Let's do it. Can I erase?
No.
No.
halfway done. Almost done. Do you remember the definition of net force?
Combination of all forces.
That's the most important part. You know what it means.
Yes, I
The
know.
vector sum.
Yes.
How many vectors do I have up here? 2. So all I gotta do now is what? Add them. I'm gonna add these vectors. First we calculate the magnitudes, now we're gonna add them. These are the magnitudes. The directions are there on the diagram. So let's add them. This is f of b on A, f of c on A. Y, x. And if you recall how to proceed, this is for f of c on A, f of b on A. Is it coming back yet?
Yeah.
Y, x, y, x. So what I need, no, I don't like it. Okay, what I need here, up here, I need f of c on A. I need the x component, and I need the y component. Okay? Down here, this is f of b on A. I also need the x component. F of b on A, I need the y component. Okay, what's the x component for this? There is no x component, that's 0. What's the y component for this?
9.
It's 90. What about this one? What's the x component?
100.
100. What's the y component?
0.
0. There you go. You just read it off. If you don't remember this, go back and check your notes. Okay, so now, what we need to do, you guys get all of this because I'm going to erase this. Okay? So now, I need to get F net. F net is equal to F net x square F net y square square root. So what is F net x? It's all, you add up all the x components, right? So here, this is my first x component. This is my next x component. So what's my total next x component?
100.
100, so F net x is 100. Then I add up my y components. This plus this.
90.
Somebody calculate and tell me what you get. You should get 130. You can double check. That's what you should get. Okay? So now, this is the magnitude of the net force. We need to get the direction of the net force, which is the last thing we do. Inverse tangent of F net y over F net x. And the x component is what? 100? It's 100 at the bottom. And at the top, it's